All right, so it's Chapter 4, Section 4, Day 1. We're going to graph sine today, the sine function. We have the vocabulary words that I've already gone through. So the parent function is, here's the transformation form. And we're talking about sine. So y equals sine x. The number in front of sine, if there's not one there, that means it's 1. It's 1 sine. It's the a value. And the amplitude is the absolute value of a. So in this case, it's 1. So absolute value of 1 is 1. So the amplitude is the distance from the midline. So from the center, we go up 1 and down 1. So that's the amplitude. It's in each direction. Sine is the function, and the number in front of the function is your b value. And you need the b value to determine the length of your period. B, when there's not 1 here, it's 1x. So b equals 1. Thank you. Oh, sorry. So b equals 1. And we use the formula 2 pi over b. If b is 1, then it's just 2 pi. That's the standard period length because that's one time around a circle. What we're doing is graphing each quadrant of the circle on an xy coordinate plane. So every time we do a sine or a cosine graph, we're going to make 4 marks on the x-axis. And notice I didn't do 1 block for my 1 space. If I do 1, then it's going to be really cramped and hard to read. So never do 1. Always do it can be more than 2 spaces, but go up a number of spaces and then mark it whatever it is. So I'm calling 2 blocks 1. And then every time on my x-axis, I'm going to go over 2 blocks, put a line, 2 blocks, put a line, 2 blocks, put a line, 2 blocks, put a line. So that's the quadrant 1, quadrant 2, quadrant 3, quadrant 4. And the value at the end, the fourth, that's 1 period. So whatever you get from your 2 pi over b, that is the length of the period. It's not always 2 pi. It is if we're talking about the unit circle, but sometimes we're graphing sine and cosine of other things, and it'll be a different length. And so you find the 4th mark, and then cut it in half, and it gives you the 2nd mark. So 2 pi divided by 2 is pi. Cut that in half, so that's pi over 2. So now I know each section is pi over 2 in length. So that's 1 pi over 2, 2 pi over 2, 3 pi over 2. And if you follow that process every time, then you'll be able to figure out these values. The way I remember the graph of sine is Sahala. So right here I have S-A-H-A-L-A, Sahala. The S is for sine. I have a different one for cosine. We'll talk about that tomorrow. So sine is axis high, axis low, axis. That tells me where to plot my points. So sine, when I plot it, I start on the x-axis, plot a point, axis, and then I go high for the wave, plot a point, and then go back to the axis, plot a point, go low, plot a point, and back to the axis and plot a point. That's the sine wave. Axis high, axis low, axis. I'm sure there are other YouTube videos that have ways of remembering this. This is the one that works for me. Sahala. Go Sahala for sine. All right. And if it helps to put these little boundaries, you can sketch boundaries, like bumper lanes in bowling. Just kind of keep you inside the lines. Make sure your points get on the right spot. You can. You don't have to put those there if you don't want to. Okay, so now I have 4 examples of transformations. And it uses this whole side of paper. So part 3 is transformations. Oops, you can't see what I'm doing. Transformations. First one. We're going to graph f of x equals 5 sine x. So we need 2 things. We need to know the amplitude and the period. amplitude is going to come from the A value. That's the A value, A equals 5. And the amplitude equals the absolute value of A. So since A is 5, the absolute value of 5 is 5. So I know the amplitude of my graph is 5. So I'm going to go from the x-axis, I'm going to go up 5 and down 5. I'm going to go ahead and find the period length also before I start graphing. I need the b value. The b value is always in front of x. Here's x. There's nothing there in front of it, so that means I have 1x. That's b equals 1. So the period is 2 pi over b. If b is 1, that means it's 2 pi. Okay, so now I have information to graph. See, I need 5, 4, 3, 2, 1. There's my x-axis. 1, 2, 3, 4, 5. And then go there. And there's my y-axis. Here's the x. So 1, 2, 3, 4, 5. Oops, I won't do that in pink. Because my amplitude is 5. So I went up 5 for an amplitude 5, and then I'm going to go down 5 for the negative direction. That's negative 5. Every time I put 4 marks on the x-axis for the 4 quadrants, I'm going to do 2 blocks, do a line. 2 blocks, make a line. Quadrant 3 and quadrant 4. The period is the 4th line. So that's the total length of my period here is 2 pi. And then I have to fill in the rest of the values. When it's the standard 2 pi, it's pretty easy to fill them in. Go to the middle ones. Half of 2 pi is 1 pi. Half of 1 pi is pi over 2. And so then that's 1 pi over 2, 2 pi over 2, 3 pi over 2. So I have my x-axis labeled. Now I just need to graph it because there's nothing else going on in my function. Remember I said I used Sahala. Ha-la. And that tells me that sine is axis, high, axis, low, axis. So I'm going to go to my graph and I'm going to put a point on at 0. I'm going to be on the axis. And then my first mark, I go high. So I'm going to go to the top. And then I go back to the axis again. And then I go low. And then back to the axis. Once you have the pattern plotted, then you can connect your dots. Make sure you curve this. This is a wave. This is not pointy peaks and valleys. These are, when they're stretched, ooh, that wasn't very good. When they're stretched, it's harder to make it curvy. That's not very pretty in the middle. That's all right. But there's the sine function. So number 2. We have f of x equals negative 4 sine of 3x. Okay, so before we start with the amplitude and the period, there's something else on this one. This one is negative. So what does it mean when you have a negative function? Yeah, it's reflected over the x-axis, right? You have a vertical reflection. So that's what the negative sign does. So reflect over x. So you save that for the end. but don't forget about it. Because the a value is -4, a equals -4, but the amplitude is the absolute value of -4, which is 4. So I'm going to go up 4 and down 4 from the x-axis, or from the midline, I should say. And then I need to find out the length of the period. So I need the b value. The b value is in front of x. You have to be careful with the number in front of x, because if there's x plus or minus something, you have to watch out for that. This one's an easy one, so it's just b equals 3. So then the period is 2 pi over 3, because 2 pi over b. So the period length is 2 pi over 3. Once we have that information broken down with our notes, we can set up our graph. That's my ruler. Okay, so here, it's probably too long. That's 4, 3, 2, 1, 0. That puts my x-axis right here. 3, 4. So I have 4 and -4 because of the amplitude. And then 2 spaces in a line, quadrant 1, quadrant 2, 3, and 4. The length at the end of quadrant 4 is the length of the period, which I have here as 2 pi over 3 this time. All right, so this time when I need to fill in the other points on the x-axis, it's a little trickier. Here I have 2 pi over 3. So half of 2 pi over 3s is 1 pi over 3. So pi over 3 is halfway. I need to cut pi over 3 in half. What's half of pi over 3? Pi over 3 times 1/2, pi over 6. So I know each quadrant is pi over 6. So that's 1 pi over 6, 2 pi over 6, 3 pi over 6. So that's 3 over 6. 3 over 6 is half. So pi over 2. Does that make sense? No? Okay, let's go over it again. The length, right here, we're good with the fourth line, right? That came from the period that we got 2 pi over 3. So if there's 4 lines, halfway would be half of this value. So if I count, if these are pi over 3s, we'll just say that's like the object of what they were. These are pi over 3s. I have 2 of them. So if I want to go half that distance, I'm just going to go 1 of them, right? So pi over 3 is half of 2 pi over 3. What's half of pi over 3? Half of 1/3. So I want to split. So I have pi over 3. Divide by 2 is the same as multiply by half, right? So I say times 1/2. So then on the top I have pi, and on the bottom I have 6. So each section, that gives me the smallest section, is pi over 6. So that's 1 pi over 6, 2 pi over 6, 3 pi over 6. Because each one of these is a pi over 6, right? This is one of them. This is 2 of them, and it reduces. 2 over 6 would reduce to 1/3. And then 3 over 6. 3 over 6 is 1/2, so pi over 2. So you have to be careful. It can be tricky to do these. But if you follow that same, cut it in half, and then go 3 of them. Okay, so then there's 2 different ways we could do this next part. One, which is the way I tend to do it, is I remind myself Sahala. Sine is axis high, axis low, axis. But I still do need to reflect it. But if I do it, when I do vertical or horizontal shifts, I like to do a sketch first, then shift it. It's easier for me that way. So I'm going to do axis, high, axis, low, axis. And I'm just going to do a light dashed line because I'm not finished. I know I'm not finished. This is just like a partial step, breaking it into pieces because I still need to reflect it. So to reflect it, I know if a point is on the x-axis and I reflect it over the x-axis, it hasn't moved. So these points are stationary. They didn't move. But this one that is up high reflects down here. And this one that was down low is going to reflect up here. And that's going to be my reflected sine. Oops. I'm doing a terrible job of graphing. So I took the purple one and I reflected it. Some people just like to do this going backwards, this Sahala. Just if you want to reflect it, you could just do axis low, axis high, axis. You could do it, just read it backwards. I feel like there's more room for error doing it that way. It's like taking a trick and then making a trick out of the trick. It's not the best. Well, like Sahala is it like just a way to remember it. So then if you're going to remember to do a reflection by doing Sahala backwards, I don't know. I think it's better to sketch it and then reflect the points. But whatever works for you is fine. All right, example 3.
How many examples?
We have 4. All right, graph f of x equals sine, parentheses 3x minus pi over 2. So this one's getting pretty complicated. We can start them all the same way. Start with a and b. A, what's in front of your function, sine or cosine? There's nothing there, so that means it's a 1. So a equals 1. So the amplitude equals 1. So that we know we're going to go up 1 space and down 1 space from the midline. The b value. B value is not only what's in front of x, but what's in front of the parentheses of x. So your b value has to be here. This b value is inside the parentheses. So I have to factor this 3 out. Like if it was a greatest common factor, I would divide both of these by 3, right? That's pretty much what we're doing. We need to divide by 3 to get this number out because it's going to change the horizontal shift. It's not going to be pi over 2 anymore. It's going to change. So this equals sine. Now we have 3x divided by 3 is 1. We brought the 3 to the outside. So now we have x. And negative pi over 2 divide by 3. So that's like multiply by 1/3. So negative pi over 6. Negative pi over 6. So now we have another transformation. Right here. We have a c value. C equals pi over 6. So this is x minus pi over 6. X minus means we're going to shift to the right. So this is a phase shift right. Phase shift right. Pi over 6 units. All right, so we get all that figured out. I'm going to start this one over more to the left because I do know I'm going to shift it to the right. Do it about right here. So this was amplitude 1. So remember, if it's 1, use 2 blocks for a 1. So it's not all squished together. So positive 1, up 1, and down 1, negative 1. Mark each quadrant. Quadrant 1, 2, 3, 4. Oh, we never got the period. We found the b value. This is b. So 2 pi over 3. That's the period. So 2 pi over 3. That happens to be the same one as what we did on the last problem. So we know the x-axis values are going to be the same since it's the same period, 2 pi over 3. So we would cut that in half, and that would be pi over 3, then pi over 6, and then pi over 2. Again, we're doing sine. All right, so before I do a phase shift or a vertical shift, I like to do a quick sketch, a light sketch of what my function looks like right now. So I'm going to go axis, high, axis, low, back to the axis, and I'm going to do a dash. Because I know I'm not finished, but I think it's better to do it this way. That's what it looks like right now, but I still need to do a phase shift to the right by pi over 6. So the furthest right point is this one, and I need to go right from there pi over 6. But look, this is pi over 6. So one section is pi over 6. So that means I could take my dot as 0, and I could shift it to the right one section, and then I would be at pi over 6. So then I would take this dot here, shift it over, and it would go there. This one comes over to the next line. This one comes over to the next line. And then this one goes over to the next line, but there's nothing there, so I'm going to have to add a mark, because that's where my point is, and I'm going to need to label the value there. I can go ahead and fill it in. I just need to figure out what is the value at that last point. So before that was 2 pi over 3. And then I added another pi over 6. So plus pi over 6. To add fractions, I need a common denominator of 6. So I need to say times 2, which makes that 6, times 2 makes that 4. So now they have a common denominator, 6. 4 pi plus 1 pi gives me 5 pi. So that means this value is 5 pi over 6. So that's why before you do a horizontal or vertical shift, most of the time, just sketching it first and then moving each dot over that much. I feel like
the number by that 36?
Number by 6. I multiplied by 2 to make it 6 and multiplied by 2 to make it 4. So they have a common denominator. All right, one more, because we haven't done a vertical shift yet. So f of x equals sine, parentheses, x plus 2 pi minus 1. I'm going to graph that one. There's a lot happening in that. But we'll just start the same way we've been starting. Start with A. In front of sine, there's nothing there, so that's 1 sine. So A equals 1. The amplitude is the absolute value of A, so it's amplitude equals 1. The B value, it's in front of X, but in front of X is parentheses. Lucky for us, this is a 1x, so whenever we factor out a 1, it doesn't change anything. So there's nothing there, but there's also not a number right here, so we're good. So B equals 1. So then the period is 2 pi over B. 2 pi over 1, that's just 2 pi. So we have the standard period length. That makes it nice for us also. We have inside the parentheses, there's a transformation. If that's plus 2 pi, that means the C value must be negative 2 pi. C equals negative 2 pi, which is a phase shift to the left. If it's X plus, it goes to the left. Phase shift left. And then last, we have a D value on this one. D equals negative 1. So that is a vertical shift down 1. So vertical shift down. So go through your function, label all the parts, make all your notes, and then you can set up your graph. So I'm shifting left, and I'm shifting left by a lot, 2 pi. The period is 2 pi, and my shift is negative 2 pi. I'm going to shift this whole period over by the whole amount. So I know I'm going to need space on the left and the right. Do it here. And then put this here. All right, so I start this. There's my amplitude 1, and down 1, negative 1. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. Quadrant 4 is a value of 2 pi. So then half of that is pi. Pi over 2. 3 pi over 2. So when I get ready to graph this, before I do my phase shifts, because I like to graph it first, but then I notice this is shifting the entire period length. So that's actually a pretty easy shift. So the whole thing from 0, if I shift it to the left 2 pi, well, this all 4 marks are 2 pi. So if I want to take 0 and shift it to the left, I need 4 more marks. So I'm going to go 1, 2, 3, 4. So to the right is pi over 2, so the left would be negative pi over 2. And then negative pi. Then negative 3 pi over 2. And negative 2 pi. So I'm moving this entire period over. I'm just taking the whole thing and sliding it over. So that means for my sketch, before I do my vertical shift, I want to sketch it. Sahala is axis high, axis low, axis. So axis high, axis low, axis. And do a sketch. But all I have left is I need to shift it down 1 unit. So at the beginning I said when I talked about midline, when you do a vertical shift, you shift the midline. All of these, the midline, or think of it kind of like an equator, has been the x-axis. They haven't moved up or down. Now I'm going to move it. So I'm going to move the midline off of the x-axis. There's the x-axis. There's my -1. And I'm going to draw a new midline, or you can call it a new axis if you want. So that's my new midline / axis. All right, but if this is my -1, and whenever I do my axis high, axis low, I need a value below it, so I need to also take the bottom bumper pad, my bowling bumper pads, and move it down again. So I need another value down here. That'll be -2. And now I can go to my new midline and do this as axis high, axis low, axis. So there's the final one. You only have 5 problems for today, page 264. And we're going to graph cosine tomorrow. So tomorrow's notes should not be as long because it's pretty much the same process. It's just, instead of Sahala, we're going to do something different. 14, 17, 19. But it all works the same. All the transformations and everything for cosine work the same. It's just we don't plot axis high, axis low, axis. Okay.